Negative areas. Let's have a look at an example. Find the area under y equals x squared minus 2x in the region x lies between 0 and 2. Well, to solve this, we set it up as an integration sum. The area is the integral of x squared minus 2x dx between 0 and 2. Now we can integrate that. X to the power 2 becomes x to the power 3 over 3, and minus 2x becomes minus 2x squared over 2 between 0 and 2. Now that simplifies to 1/3 x cubed minus x squared between 0 and 2, and we substitute 2 into the formula and then subtract what we get when we substitute 0 into the formula. And that gives us 1/3 times 2 cubed minus 2 squared, take away in brackets 0 minus 0. Well, that's 8 over 3 minus 4, which is 8 minus 12 over 3, or minus 4/3. So the area appears to be minus 1 1/3. But areas are positive, so how can an area be less than 0? Well, let's look at the graph. We see the area we want lies below the x-axis. When we integrate, areas below the x-axis are evaluated as negative numbers. So to find the area, we should take the positive value. So in this example, the above area is 1 1/3. Let's have a look at another example. Example 2. Find the area between the graph y equals x cubed minus 3x squared plus 2x and the x-axis in the region x lies between 0 and 2. Well, to solve this, we have the area is the integral of x cubed minus 3x squared plus 2x dx between 0 and 2. And when we integrate that, we get the area equals, now x to the power 3 becomes x to the power 4 over 4. Minus 3x to the power 2 becomes minus 3x to the power 3 over 3, and plus 2x becomes plus 2x squared over 2 between 0 and 2, and that simplifies to x to the 4th over 4 minus x cubed plus x squared. Now we substitute in the value 2, and then we take away what we get when we substitute in the value 0. So that gives us 2 to the power 4 over 4 minus 2 cubed plus 2 squared, take away 0 minus 0 plus 0. So the area works out to be 4 minus 8 plus 4, which gives an area of 0. Now that shouldn't give us an area 0 because the graph does not lie on the x-axis. But if we look at the graph, we see half the area we want lies above the x-axis and is positive. Half the area we want lies below the x-axis and counts as negative. So the total area is evaluated as 0. Now this is not correct. So to find the total area, we must calculate the areas A and B separately. A is above the x-axis, B is below the x-axis. We must make them both positive and then add them. So area A is the function x cubed minus 3x squared plus 2x integrated between 0 and 1. So that's x to the 4th over 4 minus 3x cubed over 3 plus 2x squared over 2 between 0 and 1. Or if we simplify it, x to the 4th over 4 minus x cubed plus x squared between 0 and 1. So we substitute 1 into the equation, and we subtract, substituting 0 into the equation. So that gives us 1 to the power 4 over 4 minus 1 cubed plus 1 squared, take away 0 minus 0 plus 0. And that gives us 1/4 minus 1 plus 1, and so area A is 1/4. Now we can do the same thing with area B. We're integrating the same function, but this time between 1 and 2. And so it integrates in the same way and simplifies to x over 4 to the 4 minus x cubed plus x squared between 1 and 2 this time. So we substitute 2 into the equation and take away what we get when we substitute 1 into the equation. So that is 2 to the 4 over 4 minus 2 cubed plus 2 squared. Take away 1 to the 4 over 4 minus 1 cubed plus 1 squared, which gives us 4 minus 8 plus 4. Take away a quarter minus 1 plus 1. And that simplifies to minus a quarter. Now the area has to be minus a quarter made positive, so that's plus a quarter. So the total area of A plus B is a quarter plus a quarter, which equals a half. So our answer is the total area is a half. So from this we see, when calculating the area between a graph and the x-axis, we must work out which parts of the graph lie above the x-axis and find their areas. We must then find the parts that lie below the x-axis, find the areas by integration, and then make the values positive. Finally, we add to get the total area. Let's have a look at an example. Here we've got a picture of a graph, and if we're asked to find the area between the graph and the x-axis in the diagram, for x lying between -3 and 10, we should divide it into sections that are above or below the x-axis. For area A, integrate between -3 and 0, and then change the sign. For area B, integrate between 0 and 6. And for area C, integrate between 6 and 10, and then change the sign. And then finally, we add the areas A, B and C. Now the following is an exercise. Pause the video at this point, have a go at the questions yourself, and when you've done what you can restart the video and I'll go through the answers. Okay, let's go through the questions. In question 1, part 1, we're asked to find the 2 points where the graph y equals x squared minus 4x minus 5 crosses the x-axis. Well, to solve this, let x squared minus 4x minus 5 equals 0. Now we can factorize that. We want two numbers that multiply to make minus 5 and add to make minus 4. They are minus 5 and plus 1. So that is x minus 5 into x plus 1 equals 0. Now when two things multiply together to make 0, one of them must be 0. So x minus 5 is 0 or x plus 1 is 0, which means x is 5 or x is minus 1. Now in part 2, we're asked to sketch the graph. Now we know the graph crosses the x-axis at -1 and 5. The graph also crosses the y-axis when x is 0, so y is minus 5. The graph is a U-shape because the x squared coefficient is positive. Hence we can draw the graph. Now in part 3, we're asked to find the area between the graph and the x-axis that lies between these 2 points. Well, the first thing we notice is that the entire graph lies below the x-axis, so we only have to do one integration. We integrate x squared minus 4x minus 5 between -1 and 5. Now when we integrate x to the power 2, it becomes x to the power 3 over 3. Minus 4x becomes minus 4x squared over 2, and minus 5 becomes minus 5x. We substitute 5 into the equation, followed by taking away, substituting minus 1 into the equation. So that gives us 5 squared over 3, minus 4 times 5 squared over 2, minus 5 times 5, take away, in brackets, minus 1 cubed over 3, minus 4 times minus 1 squared over 2, minus 5 times minus 1, which comes out to be 41 2/3 minus 15 minus 25, take away minus 1/3 minus 2 plus 5. Well, we can eliminate the brackets, and that gives us minus 36. So the integral gives us minus 36. So the area between the graph and the x-axis is plus 36. So our answer is the area is 36. Now in question 2 part 1 we're asked to find the roots of the equation x squared minus 3x minus 4 equals 0. Well, we start with x squared minus 3x minus 4 is 0 and we factorise it. We want two numbers that multiply to make minus 4 and add to make minus 3. They are minus 4 and plus 1, and so we have x minus 4 times x plus 1 equals 0. Which means that x minus 4 is 0 or x plus 1 is 0, so x is 4 or x is minus 1. So our answer is x is 4 or minus 1. Now in part 2 we're asked to sketch the graph of y equals x squared minus 3x minus 4. And we know the graph crosses the x-axis at minus 1 and 4. If we let x equal 0, we see that the graph crosses the y-axis at minus 4. Now that means we can sketch the graph as we know it's a U-shape. Now in part 3 we're asked to find the area between the function and the x-axis in the range x lies between 1 and 6. So we want the area between 1 and 6. Now we've got two areas, one is below the x-axis and one is above the x-axis. So to find the area below, area A, we have the integral from 1 to 4 of x squared minus 3x minus 4. And to work that out we have the integral of x to the 2 is x to the 3 over 3. The integral of minus 3x to the 1 is minus 3x to the 2 over 2. And the integral of the number minus 4 is minus 4x. Now we substitute in the values of 4 and take away when we substitute the value of 1. So that gives us 4 cubed over 3 minus 3 times 4 squared over 2 minus 4 times 4. And we take away 1 cubed over 3 minus 3 times 1 squared over 2 minus 4 times 1. Which gives us 21 and a third minus 24 minus 16. Take away a third minus 1 1/2 minus 4. And that works out to be minus 13 1/2. So the area A is plus 13 1/2. Now to work out the area B, we integrate the same function, but this time between 4 and 6. So the integral is the same between 4 and 6, and we simply substitute in 6 and 4. So we get 6 cubed over 3 minus 3 times 6 squared over 2 minus 4 times 6. Take away 4 cubed over 3 minus 3 times 4 squared over 2 minus 4 times 4. So that's 72 minus 54 minus 24. Take away 21 over 3 minus 24 minus 16, which works out to be 12 2/3. So area B is equal to 12 2/3, which means the total area A plus B is equal to 13 1/2 plus 12 2/3, which gives a total area of 25 5/6. In question 3, part 1, we're asked to solve the equation x cubed minus 3x squared minus 13x plus 15 equals 0. Well, if we look at the last integer, 15, that's got factors 1, 3 and 5, so it's worth trying plus or minus 1, plus or minus 3 and plus or minus 5. So let x equal 1. Then y equals 1 cubed minus 3 times 1 squared minus 13 times 1 plus 15, which works out to be 0. So 1 is a root. If we try x equals 3, then y equals 3 cubed minus 3 times 3 squared minus 13 times 3 plus 15, which is minus 24. If we try x is minus 3, then y equals minus 3 cubed minus 3 times minus 3 squared minus 13 times minus 3 plus 15, which does work out to be 0. So minus 3 is a root. And if we try x equals 5, then y is equal to 5 cubed minus 3 times 5 squared minus 13 times 5 plus 15, which is 125 minus 75 minus 65 plus 15, which is 0. And so we have the roots are minus 3, 1 and 5. Now in part 2 we're asked to sketch the graph of the equation y equals x cubed minus 3x squared minus 13x plus 15. Now the graph crosses the x-axis at minus 3, 1 and 5, and it crosses the y-axis when x is 0, so it crosses the y-axis at 15. Now we know it's a cubic equation, so it's a kind of S shape, and we can sketch it. Now in part 3 we're asked to find the area between the graph and the x-axis that lies in the region between the lowest and highest roots. That is between minus 3 and 5. Now some of the graph lies above the x-axis, we can label it A, and some of the graph lies below the x-axis, we can label it B. And we need to find each of those areas individually. So for area A, we integrate the function between minus 3 and 1. Now when we integrate x to the power 3, it's x to the power 4 over 4. When we integrate minus 3x squared, you get minus 3x cubed over 3. When you integrate minus 13x, you get minus 13x squared over 2. And when you integrate 15, you get 15x. And we substitute in the value 1, and then we take away substituting in the value minus 3. So that gives us a quarter minus 1 minus 13 over 2 plus 15, take away, in brackets, minus 3 to the power 4 over 4, minus 3 times minus 3 cubed over 3, minus 13 times minus 3 squared over 2, plus 15 times minus 3. Which all simplifies to 7 3/4 take away, in brackets, 20 1/4 plus 27 minus 58 1/2 minus 45, which is 7 3/4 take away minus 56 1/4, which equals 64. So the area of A is 64. Now we do exactly the same for area B. We integrate the same function, but this time between 1 and 5. And when we integrate it, we get the same function as before, between 1 and 5. And so we substitute in the values of x as 5 and take away substituting x as 1. So that gives us 5 to the 4 minus 3 times 5 cubed over 3 minus 13 times 5 squared over 2 plus 15 times 5. Take away, in brackets, a quarter minus 1 minus 13 over 2 plus 15, which works out to be 156 1/4 minus 125 minus 162 1/2 plus 75, take away 7 3/4, which is minus 56 1/4 take away 7 3/4, which is minus 64. Now the integral is minus 64, so the area is plus 64. So area A is 64 and area B is also 64. So that gives us a total area of 128.